Okay, this is the last question. It's a contingency table question where they gave you all this stuff here. There's people who have preferences for going on their holiday. There's 180 staff members altogether. And I think 83 are male and 97 are female. And it all adds up to 180 people. But it turns out that 98 people would like to go to the coast, 46 of them male and 52 female. It looks like 62 want to go to the game park, 36 female, 24 male, and 20 would just like to stay home, and that's 7 female and 13 male. It's good to understand the table and be able to read it. Now it says, determine the probability that a randomly selected staff from the whole staff is male. Well, what you do is you go over here, and probability of being male is the total number of people there are and how many males there are. So it's 83 out of 180. So the probability that a person will be male is 46.11%, 83 over 180, and that's it. Okay, what's the probability that a person does not prefer visiting the game park, does not like the game park, does not want to go to the game park? Well, the way you could do it is you've got 62 people kind of want to go to the game park, but I'm looking at 98 and 20 that don't want to go to the game park. 98 want to go to the coast, 20 want to stay at home. If we add those two together, we get 118 people that don't want to go to the game park, that are outside the game park choice. So that's why it's 118 out of 180, a 65.56% chance. Now, the next question involves some more understanding of different things. I think it's this question that if the events being male and staying at home are independent events, we're supposed to try and figure out whether those events are independent. Well, there's a formula for it, If they're independent, then the probability of one thing times the probability of the other will equal the probability of their intersection. So what you can do, and this is what you do, you just take a look. Is the probability of being male and the probability of staying home? You work them out. Well, the probability of being male, we've done it. It's 83 over 180. The probability of staying home is 20 over 180. Well, what we do is we take those things and we multiply them, and we check and see if it equals the probability of being male and staying at home from the table. So we look at the probability of being male and staying at home. It's 13 over 180. Does it equal the probability of those two things separately multiplied together? No, it doesn't. So we would say, no, these are not independent events. These are not independent because they don't equal each other. This is the test for independence. If you want to see if two things are independent, if you multiply their individual probabilities together, you should get the probability of their intersection. And the probability of their intersections in the table, the probability of staying at home and being male, is 13 out of 180, but it doesn't equal the individual probabilities multiplied together. So it's not independent. If they ever say, see if they're independent, always write down this formula, memorize this formula, and then just stick in the fractions and see if it's true. That's how you do a question like that. Okay.